All right, so those were the creational patterns. Now let's talk about the structural design patterns. There are more of them than there are creational ones. So first of all, we looked at an adapter which converts the interface that you get from some system or other to the interface that you need. We also discussed the fact that an adapter, by virtue of performing the conversion, can spawn additional objects. It can spawn additional data, and if you are calling the adapter many times on the same data, then it might make sense to actually cache the results of the adaptation. So if your adapter generates some temporary information, you might want to cache this information for subsequent calls. Then we looked at the bridge design pattern, which simply decouples the abstraction from implementation. So instead of having that sort of Cartesian product explosion in the number of subclasses, what you do is you use composition instead. So you simply take out a part of the hierarchy in a separate interface, and then you refer to it via an ordinary field, for example. Then we looked at the composite design pattern, and the composite design pattern lets clients treat individual objects as well as compositions of objects uniformly, and we saw how easy it is to do this in the .NET framework, because essentially any scalar object, any singular object, can present itself to be a collection of these objects by simply implementing IEnumerable of itself. So if you have a class called foo, you implement IEnumerable of foo, and then you simply yield return this, and that way you present yourself as an enumerable collection containing just a single element, and that element is yourself. It's the class that is actually providing the functionality. Then we looked at decorator, which allows you to attach responsibilities to objects. So you have an object defined already and you want to expand its functionality, but if inheritance isn't available for you, and there are many cases where it isn't, like for example, we've seen string builder, which is a sealed class, you cannot inherit from it. So you build a decorator, you build an object which aggregates the string builder, in this case, copies all of the functionality, and suddenly ReSharper makes it easy to create all the delegating members, and then you add additional functionality on top of it, and thereby you can have a decorator on top of that object. And you can also have decorators of decorators. Unfortunately, because in C# you cannot inherit from a type argument, you cannot automatically get all the object's behavior by inheritance. So in C#, the decorator is usable as a dynamic property, a dynamic decorator that you construct by passing the decorated object as a constructor argument, but having a decorator which uses inheritance and uses the layering of generic arguments is not a feasible approach, unfortunately, in the .NET framework. So moving on, let's talk about more structural design patterns. So we looked at facade, and facade essentially provides a single unified interface over a set of classes or systems. And this is one module where instead of doing a synthetic demo, I've showed you something which is real world, which is a console class which actually hides behind itself a rather large set of subsystems, and it provides a high-level interface. So you can take a console and you can write line on it, but on the other hand, you also have access to all the internals, all the buffers, the viewports, the texture manager, and so on. And this is something that is a design decision. So essentially you can have a facade which just exposes the commonly accessible information, the kind of high-level designs, but you can leak some of the implementation details through the facade, and there is no problem in it. And that way you are serving two different groups of people. You're serving people who just want to get things done, and they get the high-level interface, the sort of unified, single, usable interface, but you also get the power users that way. So you serve the power users who maybe want to customize the system a little bit, and you give the functionality for that as well. Then we looked at the flyweight design pattern, which is a way of efficiently supporting the very large number of similar objects, and it's essentially a space optimization technique. So when you have a game with many people called John Doe, for example, what you might want to do is not store John Doe in every single row of a database, if that is what is being suggested here. Instead, you keep the names separate, and then you have links to those names. So if 100 people are called John Doe, they all have just a single integer pointing to that particular name. Then we looked at the proxy design pattern, and the proxy essentially provides a surrogate object which forwards the calls to the real object while performing additional functions. And those functions can be well, they can be virtually anything, but common uses of proxies are, for example, protection proxies, where you check whether the user has the access rights to call some method on a particular object, or they can be, for example, remoting proxies where the object doesn't really live on the system in the same process as the process you're working with, but having calls on that object actually sort of serializes all the arguments and passes them to, let's say, a process running on some other machine, and then the rest of the processing happens on that other machine. So there are different kinds of proxies, but the general idea is that you replicate the interface once again, but in the implementation of the interface, in addition to just forwarding the calls, you also do additional operations. Now, we also have this thing called dynamic proxy, which is very popular in .NET and elsewhere. And that dynamic proxy, instead of having the proxy made at compile time, where you make the proxy by making the appropriate classes and whatever, it actually creates a proxy dynamically. So this is dynamic programming. It's basically constructing types at runtime as opposed to compile time. And the upside here is that in certain cases you don't have to manually replicate the target object API. Instead, what you can do is you can specify additional behaviors to be added to every single method of a particular class, for example.